part 3 of our periodic trends videos. We have electronegativity next, and we saved the best for last. So the electronegativity is defined as the ability for an atom to attract electrons, and so we can see that as we go up and right on the periodic table, that our electronegativity increases. And our noble gases are not involved in this trend, so I crossed them out, X'd them out, blurred them out. So let's go look at our notes. So electronegativity, again, is the ability of an atom to attract electrons, and noble gases aren't included. Remember the octet rule. So all atoms naturally want or are most stable with 8 electrons in their valence shell. Remember, outermost shell is valence shell. So in the group, the smaller atoms have positive protons closer to the valence shell. So remember, with let's just say something like hydrogen, that's our nucleus, and we have one little lone electron right here. He's super close to this positively charged nucleus, and opposite charges attract. So we're feeling this strong electronegativity to this electron. And so smaller atoms are really closer, and they feel this Coulombic attraction, which in turn makes it easier to attract electrons because we have this positive closer to a different atom. Say we were with a chlorine atom, which had, let's just say, it has 7, right? And so yeah, this guy is really, chlorine is really electronegative because it really wants 8 electrons, right? Because of our octet rule. And so then we go down a period, atoms are getting, or go across a period, I'm sorry. As we go across a period, atoms are getting smaller, so we have an increase in effective nuclear charge and increasing electronegativity. So as we go left to right, we can see that we'll add more positive protons, which are pulling these electrons closer and making it so that these electrons feel a lot more of a pull over here and inducing bonds. This would be inducing a strong polar covalent bond. So let's look at a quick question real quick. Which of the following atoms has the highest electronegativity? So sodium has valence electron that's just 1, so it has a charge of +1 when bonded. Okay, so that's not going to be very electronegative because it really wants to get rid of this 1 electron, right? Because underneath this valence shell, it has 8 already, so it's really going to participate in a lot of ionic bonds where we can get rid of this one electron. So then we have oxygen. So this has 6 valence electrons, so it's going to really want 2 electrons, which, you know, that's a pretty close to its octet, but let's see if we have anything that's closer. So we have chlorine, which has 7. We just looked at a chlorine atom, so it has 7 valence electrons, and that means it's pretty electronegative, right? So we're gonna need only 1 electron to fill the octet. But fluorine is also a halogen, right? So it also has 7 valence electrons. So what's the difference in a chlorine atom and a fluorine ion? Well, their size. So fluorine is 1 above chlorine on the periodic table in terms of period, so that means it has 1 less electron shell, and the nucleus is pulling those electrons a lot closer together. And so if we look at valence electrons, we know that it can't be A or D, and since fluorine is the smaller atom, C is going to be our answer. It's going to have a higher electronegativity, and you can remember that fluorine is the most electronegative atom, and that tracks with our periodic trend, right? Because we increase electronegativity as we go up and right, so it only makes sense that fluorine is the most electronegative atom.